Hi everybody, welcome to IGTV. This is our weekly InfraGard editorial with William H. Murray on application security. Good morning, Bill.
Morning, Joe.
Go ahead, take it away.
At the recent RSA conference, friends of the late Bob Abbott gave a celebration of his life and legacy. His life was represented by his wife Alfreda and their children and grandchildren. His legacy was represented by his professional colleagues and proteges, and to a lesser extent by his work. His masterwork was the Resos paper, in which he described common programming errors that make our computer programs vulnerable to attack. This short list included incomplete data checking and enforcement. 40 years later, this is still our most prevalent and troublesome programming error. No one who makes this error is a journeyman programmer. At the programming level, this is simply a coding error, but at the application layer, it also appears as a design error. While we typically think of checking the inputs from users, that is, at the interface between the user and the computer, this failure also shows up at other interfaces. For example, between the application and the database manager, and between the database manager and the file system. It's hard to blame the programmer alone when the specification does not call for these checks. The database manager includes the ability to check inputs that it receives from the application, but we commonly fail to use this because it requires we enable it. The application does not include the ability to check what it gets from the database. It must be designed and expressed in code. Guess what? Bob also noted what he called the race condition and what my IBM colleague Bill McPhee called the time of check to time of use problem. This is inappropriate reliance upon a checked but unbound condition. The programmer checks it early, before using it, and finds it within bounds. The hacker changes it to a value out of bounds before the program uses it. You can figure out for yourself why this is slightly less common than the unchecked inputs. Don Parker was at the celebration. His presence reminded me of escape mechanisms. While these most often show up in applications, Don called me in the early 80s to report one that showed up in hardware. The protocols used in standard ASCII terminals included an escape code. User A could include this character in a message sent to user B. Everything that followed this character would be hidden from B, but returned to the operating system as input from B with B's privileges and capabilities. The notorious hacker, Robert Tappan Morris, author of the All Souls worm, is said to have danced across the desktops when he discovered the debug feature in SendMail. The .sy tag had existed in IBM's document composition facility for years before it was identified as an attack vector and fixed within 3 weeks. Similar mechanisms were featured in Microsoft Word and in Microsoft Excel. While such escape mechanisms may be useful and sometimes even necessary, they are often, as in the SendMail case, gratuitous. As its name suggests, the SendMail debug feature was included for testing purposes, but never removed. The real problem here is not so much the inclusion of the escape function as the failure to provide a mechanism to allow management or the user to control its use. When my colleague, John Tabor, identified the .sy tag as an attack vector, IBM added a control over its use. Of course, this left the question as to whether the default for the control should be forbid, safe, or permit, unsafe. We opted for the safe default, but because the control was added late, the safe default was very disruptive. And of course, none of this is to say that unsafe defaults are not high on the list of common design errors. Peter Neumann of SRI was at the celebration. His presence reminded me of a dialogue, not to say dispute, that we engaged in on the RISC forum, of which he was the historic moderator. The dispute was over online tax filing and resulted in part from a difference in our experience and worldviews. Peter lived in the Unix world, while I lived in the mainframe world. In Peter's world, most applications failed to the Unix prompt, while in mine, they most often failed, usually to log on, sometimes even to a halt. Peter was sure that users would escape the tax application and be left in a privileged state with arbitrary access to the tax data. While conceding that users might escape the application, I believed that they could and should be left by design, if not by default, in an unprivileged state. Of course, we are now doing online tax filing. As I expected, the application does not fail to the operating system or to any privileged state. However, Peter's concern is also addressed by the use of agents like TurboTax and H&R Block. While taxpayers do engage in fraud, they cannot abuse or misuse the IRS computers. Other common design errors include unnecessary complexity that causes errors and masks malice, gratuitous functionality that increases the attack surface, and inadequate controls that result in management having to choose between users having too much privilege or too little. Now, part of our persistent problem of poor application design and practice may originate in our focus on what not to do rather than on what to do. So here, and in the chat, are recommendations for secure applications. First, enforce all restrictions upon which you rely. Simply saying to the user, "Don't do that," is not an adequate control. Check and restrict all parameters to the intended length and code type. Prefer short and simple programs and program modules. Prefer programs with only one entry point at the top or the beginning and only one at the bottom or the exit. Ensure that paths through the program or application embrace but never cross. Prefer reliance upon well-tested common routines for both parameter checking and error correction. Consider the use of routines supplied with the database client. Parameter checking and error correcting code is difficult to design, write, and test, and it's best assigned to master programmers. For example, for web applications, almost everybody should be using the OWASP Enterprise Security API for this kind of checking and correction. Fail applications to the safest possible state. Prefer failing multi-user applications to a halt or logon, or to a new instance of the application. Only single-user applications may fail to single-user operating systems. Limit applications to the least possible privileges. Prefer the privileges of the user. Otherwise, use a limited profile created and used only for that purpose. Never grant an application system-wide privileges. The author of SendMail said that he never visualized the possibility that anybody would run SendMail in a privileged state. Since the programmer cannot, as in this case, the SendMail programmer, cannot envision the environment in which the application may run, and the system manager may not understand the risk, exceptions to this rule are extremely dangerous. Bind applications end-to-end to resist control bypass. Prefer a trusted single system environment or a carefully crafted combination of end-to-end encryption and dedicated path. Include in an application user's privileges only that functionality that is essential to the use of the application. Consider dividing the application into multiple objects requiring separate authorization so as to facilitate involving multiple users in sensitive duties. Controls should default to safe settings. Where the controls are complex or interact in subtle ways, provide scripts, wizards, or profiles. Prefer localized controls close to the data. For example, the file system to the application, database manager to the file system. Use cryptographic techniques to verify the integrity of the code and to resist bypass of the controls. Think tripwire. Provide feedback to users, managers, and to the subjects of the data. Consider transaction confirmations and statements. Consider out-of-band confirmations. Prefer applications and other programs from known and trusted sources in tamper-evident packaging. While these recommendations can be used as an evaluation tool late, they are better used as design criteria early. While designers and programmers may resist these on site, they seem to reflexively resist any guidance, they will eventually accept them as measures of and guides to quality. While getting timely agreement to them is easier for management and for application owners than for security personnel, that is why we are called professionals and are paid the big bucks. See you next week.
Thanks, Bill. Appreciate it. Have a good day now.
Thank you.